Hello students. Today, we are going to look at problem from irodov. The problem states, a point moves rectilinearly with deceleration whose modulus depends on the velocity v of the particle as w equals a times the square root of v, where a is a positive constant. At the initial moment, the velocity of the point is equal to v naught. We need to find two things. First, what distance will it traverse before it stops? And second, what time will it take to cover that distance? Pause the video for a minute and try this question. Now, let's move to part 1, finding the distance traversed. To start, we use the chain rule for acceleration. We can write dv by dt as the product of dv by dx and dx by dt. Since we know acceleration w is negative a root v, and dx by dt is simply velocity v, we substitute these into our equation to get v times dv by dx equals negative a root v. Next, we separate the variables. Bringing the terms with v to one side and dx to the other, we get v divided by root v times dv equals negative a dx. Finally, simplifying the left side, we get root v dv equals negative a dx. Now, let's proceed with the integration to find the total distance traversed. Starting from our previous result, we have v to the power of 1/2 dv equals negative a dx. To find the distance, we integrate both sides. The limits for velocity are from initial velocity v naught to 0, since the particle stops. For distance, the limits are from 0 to s. So, we write the integral from v naught to 0 of v to the power of 1/2 dv equals the integral from 0 to s of negative a dx. Performing the integration, the integral of v to the power of 1/2 is v to the power of 3/2 divided by 3/2. Applying the limits from v naught to 0, this equals negative a times the integral of dx from 0 to s, which is x evaluated from 0 to s. Finally, simplifying the fraction 3/2 by moving it to the numerator, we get 2/3 times v to the power of 3/2 evaluated from v naught to 0, which equals negative a times the quantity s minus 0. Now, let's complete the final calculation for the distance. Plugging in our limits, we have 2/3 times 0 to the power of 3/2 minus 2/3 times v naught to the power of 3/2 equals negative a times s. Since 0 to any power is 0, the left side simplifies to just negative 2/3 times v naught to the power of 3/2, which equals negative a times s. Finally, by cancelling the negative signs on both sides and dividing by a, we find the expression for the total distance s equals to times v naught to the power of 3/2, all divided by 3a. Now, let's proceed to part 2, finding the time taken. We start with the original definition of acceleration, dv by dt equals negative a root v. To solve for time t, we separate the variables. Moving the velocity terms to the left and the time terms to the right, we get dv divided by root v equals negative a dt. Writing root v in the denominator as v to the power of negative 1/2, our equation becomes v to the power of negative 1/2 dv equals negative a dt. Finally, we set up a definite integral. We integrate from the initial velocity v naught to a final velocity of 0, and for time, we integrate from 0 to t. So, The integral from v0 to 0 of v to the power of negative 1/2 dv equals the integral from 0 to t of negative a dt. Now, let's perform the integration to find the time taken. Integrating v to the power of negative 1/2 dv gives us v to the power of 1/2 divided by 1/2. We evaluate this from v0 to 0, which equals negative a times the integral of dt from 0 to t dividing by 1/2 is the same as multiplying by 2, so we have to root v evaluated from v0 to 0 equals negative a times the quantity t minus 0. Substituting the limits, we get to root 0 minus to root v0 equals negative at. The first term is 0, which simplifies our equation to negative to root v0 equals negative at. Finally, cancelling the negative signs from both sides and dividing by a, we find the time taken, t equals to root v0 divided by a. That concludes our lesson for today. Thank you for watching. This content is brought to you by the Ekalavya Educational Channel. Remember to keep learning and keep growing. If you found this helpful, please support our channel by liking, sharing, and subscribing.